Hello everyone, this is Dr. G. Karthik Reddy, working as Associate Professor in the Department of ECE, MLR Institute of Technology, Hyderabad. Today's topic is movements of a random variable. What is the use of these movements of a random variable? Okay, here mainly I am discussing on movements are divided into two types. Movements are divided into two types. One is movement about mean and second one is movement about origin. Before discussing about movement about mean and movement about origin, here we are discussing about movements of a single random variable. We are discussing about movements of a single random variable. Okay, these are the topics. This is overview. We are going to discuss about movements about origin and movements about mean. Movements about mean. First, we will discuss about movements about origin. What is the definition of movements about origin? Okay, here the expected value of x power n, where x is a random variable. Here x is a random variable and small x is a value assigned to this random variable. And here n value, n starts from 0, 1, 2, so on. Okay. For example, if you are this is a mathematical expression of the movement about origin. Okay. Expectation of x power n is equal to integral minus infinity to infinity. Here the integration represents the range of random variable. X lies between minus infinity to infinity, x power n, fx of x. The small fx of x represents probability density function. Probability density function. Okay. Probability density function may be anything. Okay. It can be either, okay, we have already discussed in the previous sessions that probability density function may be binomial, or it may be Poisson, or it may be uniform, or it may be Gaussian, or it may be Rayleigh, or it may be exponential, or any other density function. Okay. Here x, what is x represents here? Okay. Here, before discussing about x, if you are substituting n equal to 0, okay, if you are substituting n equal to 0, then what you are going to get? Expectation of x power 0, okay, which is equal to integral minus infinity to infinity, x power 0, fx of x dx. Okay, fx of x dx. Then what is x power 0 is 1. Then finally you are going to get integral minus infinity to infinity, small fx of x dx. Okay, this represents what? The area under the density function. The area under the density function is also known as valid density function. What is the value of valid density function? Is always equal to unity. The area under the curve. Okay, this is a random variable x. This is a density function small fx of x. This is the area under the curve. For example, interval is from minus infinity to infinity. The area under the curve of any particular density function is always equal to 1. Therefore, what we can conclude that 0th order, n equal to 0 represents 0th order. 0th order of the expectation is always equal to 1. Is always equal to 1. Now next, we'll discuss n equal to 1. N equal to 1. When you consider n equal to 1, then what you are going to get? Expectation of x power 1, which is equal to integral minus infinity to infinity, small x, small fx of x dx. Okay, don't write capital Fx of x. Capital Fx of x represents distribution function. Okay, the small fx of x represents probability density function. Okay, probability density function. Always we are giving this E of x. E represents what? Expectation. Expectation of random variable x is always lies between minus infinity to infinity. If x value lies between minus infinity to infinity, the small x is the value assigned to the random variable. This small fx of x represents density function. Okay, this is a first order movement about origin. The first order movement about origin is represented with the notation either expectation of x or m1. Expectation of x or m1. Now next, we are going for n equal to 2. N equal to 2 represents expectation of x square. Expectation of x square. This represents what? Integral minus infinity to infinity, in place of x, x square into small fx of x dx. Okay, small fx of x dx. This expectation of x square is called second order. means n equal to 2. N equal to 2 represents what? Second order movement about origin. Second order movement about origin. The other name of this is the most familiar to you, that is called expectation of x square, is called mean square value. Mean square value. Expectation of x square is also known as mean square value. Okay, this is for the continuous random variable. If x is continuous, this is the formula. If x is discrete, then what becomes the formula? Summation. Summation for maybe the I equal to, we can consider that I equal to 1 to infinity or 0 to infinity. If you are considering 1 to infinity, then xi into p of xi. This is a representation of discrete random variable. If x is a discrete random variable, then this is a formula of the mean square value. Okay, here p of xi represents what? Probability mass function. Probability mass function, short form is PMF. Okay, this is a notation. Now same thing, if you want to represent for expectation, then previously, that is first order movement, expectation of x is equal to integral minus infinity to infinity x into fx of x dx. In this case, x is a continuous random variable. Then if x is a discrete random variable, then what is the notation? In place of integration, you are going to get summation. You are taking the instance I equal to 1 to n. Okay, here xi into p of xi. Okay, p of xi. Okay, we conclude that here we are having the three notations we have discussed. N equal to 0 represents 0th order of the movement. Then what you are going to get the expectation, that is m naught equal to 1. N equal to 1 represents first order movement, that is expectation of x. You are having the formula for continuous case, integral minus infinity to infinity x into small fx of x dx. Here x is a continuous. Next, if x is a discrete random variable, then you are going to get summation I equal to 1 to n x into p of xi. Next, if n equal to 2 represents what? Second order movement about origin. Okay, this is also known as mean square value. Integral minus infinity to infinity x square fx of x dx. Okay, now next, same thing we can write this as summation I equal to 1 to n xi square p of xi. This represents what? Second order movement about origin. Okay, we can consider up to second order, it's enough, because we can get actual, exact equal to approximate solution. The exact solution will become, okay, if you are having exact solution up to x power, expectation of x power n, you will get almost 99% you will get from up to mean square value. No need for the further calculation purpose. Now next, we are going to discuss about the next topic. Before discussing about the next topic, first you have to know that, okay, here expectation of x. Okay, the expectation of x, you have written the formula integral minus infinity to infinity x into fx of x dx. Okay, here it is variable. Okay, if you are having the function expectation of g of x, then how we can write? Integration minus infinity to infinity g of x fx of x dx. Okay, here in this case, this is a function, this is a density function. Okay, this is a function and this is a density function of random variable x. Okay, this is a case for continuous random variable. Now next we are going to discuss discrete random variable. Okay, same thing, summation I equal to 1 to n g of xi into fx of x dx. This is the case for discrete random variable. Okay, these are the differences between continuous and discrete random variable. Okay, now some more examples we are going to discuss here. For example, expectation of ax. What is the formula for expectation of x? Here x is a random variable, a is a constant. Okay, how to write this one? this here, in this case, g of x is equal to ax. Okay. Then what is the formula? Expectation of g of x. For example, we are taking the continuous random variable. Integration minus infinity to infinity a into x fx of x dx. Okay, a is a constant, take outside. Then a integration minus infinity to infinity x into fx of x dx. Then what you are going to get? A into this formula represents what? Expectation of x. Expectation of x. Now we'll discuss one more property. Expectation of ax plus b. Expectation of ax plus b. Here a and b are constants. Then what is the formula you are going to get? Again you have to use the same formula. Expectation of x, you know the formula. Integration minus infinity to infinity x into fx of x dx. Okay, here expectation of gx in place of, okay, expectation of g of x, what you are going to get? Integration minus infinity to infinity g of x fx of x dx. Here g of x is what? What you are having? G of x is equal to what? Ax plus b. You substitute that, you consider x equal to x. Okay, the value assigned to this is capital X is equal to small x. Then what you are going to get? Integration minus infinity to infinity a into x plus b into fx of x dx. Okay, now next you split, what you are going to get here? Integration minus infinity to infinity ax fx of x dx plus integration minus infinity to infinity b into fx of x dx. Now what you are going to get? This one, this becomes what? Just now we written a into expectation of x. Next what you are going to get? This. Okay, you take b common, then what you are going to get? If you take b common, integration minus infinity to infinity fx of x dx. Okay, this integration minus infinity to infinity fx of x dx is called what? Valid density function. Valid density function. There you are going to get into b. Okay, this is a formula. Okay, expectation of ax plus b is equal to a into expectation of x plus b. Now next we are going to discuss one more property. One more property of expectation. Okay, if you are having the, for example, if you are considering if x and y are two random variables. Okay, x and y be the two random variables. Both are independent to each other. Both are independent to each other. Okay, we know the property from the independent events we already discussed. If a and b are independent, okay, independent events, p of a intersection b is equal to p of a into p of b. Similarly, we are taking from here also, or we can write this as p of a intersection b, you can also write as p of a into b. Similarly, instead of probability, we are using for expectation. Then expectation of xy is equal to expectation of x into expectation of y. Okay, this is one of the important property. When x and y are two independent random variables, then expectation of xy is equal to expectation of x into expectation of y. This one we are going to prove it. Okay, how to prove this one? We know it. We know the formula of, okay, we know the formula. What is the formula? Expectation of xy. Okay, here you can consider g of x is equal to xy. G of x is equal to xy. Then what you are going to get the formula? Expectation of xy is equal to integral minus infinity to infinity xy fx of xy. We are having two variables dx dy. Two function. Why you are going to get two function? You are having two random variables. Then we know the definition. We know the definition from the density function that when two random variables are there, fxy of x comma y. Because here we consider x and y are independent random variables. If x and y are independent random variables, then what you are going to get? Fxy of x comma y. This is called what? Joint density function or joint PDF, which is equal to fx of x into fy of y. Substitute this in the above equation. Then what you are going to get? Integration minus infinity to infinity xy fx of x into fy of y dx dy. Okay, you rearrange the terms, then what you are going to get? Okay, integration minus infinity. Okay, here you get two integrations because you are having two random variables. One is with respect to x, one is with respect to y. Okay, sorry, you are having two random variables. Then what you are going to get? Okay, here you are having x into fx of x dx. Next, one more integration minus infinity infinity y into fy of y dy. This one represents the definition of expectation of x, and this one represents the definition of expectation of y. Okay, then expectation of xy is equal to what? Expectation of xy is equal to expectation of x into expectation of y. Okay, this is one of the important property of expectation. Only when if x and y are two independent random variables. When two independent random variables are there, expectation of xy is expectation of x into expectation of y. Okay, these are the some of the important properties of movements about origin. In that, most important one is expectation, and next mean square value. Okay, these two are the very important formulas you have to remember. Okay, today's session we have discussed about movement about origin. That's all for the today's session. We'll discuss again in the next session regarding movement about mean.